Okay, I'm going to go through part 4, which is question 5 of this November 2023 paper, paper 2 from Physics IGCSE. Okay, so this question reads, a sample of steam, water in a gas state, is cooled using a very cold freezer. So it's using a very cold freezer. So this is a question from topic 5, which is on solids, liquids, and gases. Okay, so the steam is cooled, so we're taking energy out of the steam using this very cold freezer from an initial temperature of 150 degrees centigrade. Okay, so calculate the temperature, the initial temperature in Kelvin. So first of all, they want you to make sure that you know what Kelvin is, and you remember the temperature in Kelvin is a temperature in Celsius with 273 added in it, because that's the difference that it starts at minus 273. So once you add the 150 to the 273, you will get 423 Kelvin. Okay, then they've got in part B, they've drawn it as a temperature time graph, and it shows how the temperature of the steam changes from the beginning. So the beginning of the time on the time axis is at the 0 point of time. It starts off as a gas, it then condenses into a liquid, and so we're starting off as a gas. We then have a change of state called condensation, and then it changes to a liquid as you remove thermal energy from the particles that make up the water. So water in different states. And then when you get to 0 degrees centigrade or thereabouts, it will start to solidify, so you have another change of state, and you'll notice that the horizontal points where the temperature stays constant is when it changes state. And once all of the the particles in a liquid state have solidified, crystallized if you like, they become into a rigid structure we call a solid. Okay, so we're going from a gas to a liquid first, and then from a liquid to a solid next. Okay, so what are they asking? So it says the steam eventually becomes ice, water in a solid state. So it goes from gas to liquid to solid, as I've just explained. So obviously the longer it's in the freezer, the more thermal energy is taken out from the internal energy store of the particles, which is in the form of kinetic energy, if you like. Movement, gas particles move much more rapidly than when they are in liquid or solid states. It then says the graph shows 5 stages, which we just went through, labeled in the diagram as A, B, C, D, and E, and I, and this is all part of the cooling process, and they want you to identify the 5 stages that I've already talked about, They want you to state which stages involve a change of state. Well, they are the horizontal lines, as I explained, so it will be B and D, So B and D will be the answer, and they do require you to write both. If you've only put one, you will not get the mark. You need to put both, because they're both involved in a change of state. Okay? It then says, describe the differences in the arrangement. So the key term here is the key word is the arrangement of the particles. The differences in the arrangement of particles when the sample goes from a gaseous state, steam, into the solid state, ice. So when it goes from gas, you could draw diagrams. Yeah, so diagrams make it easier if you know them, but they've got to be clear and they've got to be labeled or titled as they've said in the mark scheme. So if your diagram for 2 marks, if your diagram shows that, the solid is clearly labeled, is closely packed and in a fixed or regular arrangement, that will give you 1 of the marks. And if the gas is random motion, irregular arrangement, you do not need to show the movement. Okay, that's not what they've asked for, because they've asked for the arrangement. That means in what form do they appear to be in, if you like, if you took a snapshot of them, because obviously in a gaseous state they're all moving about randomly at high speeds. Okay, so here they just want the arrangements. So when you can draw a diagram, and for a model answer, yes, which you're going to make after you watch this video, always include a diagram. That will help you with your notes. So imagine each practice exam you're doing is a way of improving your notes. You're making model answers in case such questions come up again. And they do repeat themselves in future exams. The last part of this question is to do with explain. So I've put it in red in a cloud. So explain means you will have to give the reasons and the scientific explanations. Explain whether or not the energy in the kinetic store, yes, now we're talking about topic 4, energy in the kinetic store of the particles, because remember, it's the particles that have the kinetic energy. Changes when the sample is changing state. Well, if you remember the graph, and we'll go back to the graph very quickly, if you remember the graph, during a change of state, what do you notice? You notice that the temperature is at a fixed value. Here, the temperature is at a fixed value. We call this the boiling point, and we call this the freezing point, or the melting point. Okay? So you have 2 temperatures for every substance. They will have a melting point and a boiling point. Okay? So if the temperature is constant during a change of state, that should give you a clue as to what you need to include in your explanation. So first of all, you've got to explain that when the sample is changing state, the temperature remains constant. So when the sample is changing state, the temperature remains constant, does not change. And remember, temperature in Kelvin is directly proportional to the kinetic energy of particles according to the kinetic theory of gases. Okay? So, if the speed stays constant, the kinetic energy stays constant, yeah? So, therefore, it wants you to explain whether or not the energy in the kinetic store of the particles changes. The answer is no, it doesn't. Yes? But they don't want a simple no. They want this explanation, which I've just given you, broken down into the 3 ticked statements. Okay? And that's how you get the 7 marks for this question on solids, liquids, and gases, which also relates well to the energy topic. Okay? So when we did the practice exams in my year 11 class, we did a test on units 4 and 5, which included energy as well as solids, liquids, and gases, because the 2 topics are very closely related. And you see in exam questions, you can't simply give a question which does not involve more than one topic, that doesn't involve just one topic. in other words. Okay, so I hope you found it useful again. So this is the fourth part. We've done 5 questions, and the reason I don't do more than one question is because they're so different, and then we could always use the videos as training videos for future classes. So the next question, which we'll come to after you've gone through this question, is on motion, and it's quite a long question, so I didn't want to make each video too long, because I've noticed that if the videos are too long, students tend to just zoom ahead to correct their own answers without listening to the audio, and it is the listening that helps you understand the underlying theory, and that is a key part of improving your understanding before your real exams in the summer. Okay, so remember, the reason you get high marks is because of the hard work that you put into your exams. So thanks for watching, and show your appreciation, give us a like, share it with your friends in other schools as well, so they can see if they find it useful. Add a comment if you've got any questions. Feel free to ask on the YouTube channel, and then make sure you subscribe so you know when the next videos are uploaded. Bye for now.